When you start designing, you will make mistakes, and you need to know how to fix them. In this video, we will shed some light on some of those mistakes, and how we are going to fix them. Our main objective is to optimize the form, or the mesh, we have created. In this demonstration, we will remove some loops, correct others, and solve some triangles. We need to achieve this without spending too much polygons. We will add supportive loops where they are needed. We are going to direct, control, and dictate the TurboSmooth modifier in more advanced ways. Without any further delay, let's jump into it. We need to emphasize some basic concepts for you to understand what you are going to watch in this demonstration. All vertices of this plane are equally distributed. This is the ideal form of this plane surface. However, when we slide or move these vertices, we will disturb their balance. By sliding this top middle vertex to the left, we have created tension on the top corner vertex. This tension will vary regarding to the distance between the edge vertex and the ones we slid. The shorter the distance, or the edge, the higher the tension. Whenever we need to add supportive loop for the left edge, this will happen. The supportive loop we just added has unequal tension over the left edge. We need to equal the length, or the scale, of these ring edges that carry the supportive loop. If we do not adjust the flow direction of the supportive loop to match the edge we need to support, there will be strange or weird shadows or reflections happening over the left edge when extruding it. I am using the scale tool. In combining with constraint to edge, you can also achieve this by using a line to the x-axis. For your information, there is a script to equal the length of the ring edges. However, in this demonstration, I will be using the standard tools. There will be no tension variation along the supportive loop of the extruded side. However, there is unequal tension happening on the top edge, with or without adding a supportive loop. When applying TurboSmooth modifier on the top of this form, we will have a clean edge result with perfect loop flow direction. The ideal technique to create an opening or a hole in the surface is by creating a supportive loop first, then extrude, or delete the inside polygons. The inserted edge loop through these polygons will have equal tension when placing it correctly, into the middle. While what you just witness looks fine, we do not want any triangle or corners along any main edge loop. Avoiding those kind of edges is crucial if you are going to add Turbo Smooth modifier. When you add more details and move things around, the polygons loop, or the supportive loop, may lose its balanced tension. Notice how these ring edges lost their unified length. Trying to fix the tension with the scale tool does not work in the ring loop. In this case, you might need to manually correct the tension for each ring edge. Now you should have a clean result when applying Turbo Smooth modifier. A complete understanding of the supportive loops, and vertex, or edge tension, and how to utilize them, will lead to better flow direction over the form, or the geometry. And that will ease the process of designing, and the speed of your workflow. When you add Turbo Smooth modifier on top of the form, it will smooth, equally distribute vertices along loops, and it will also insert more loops, and correct the loop's flow, or the curved surfaces. It will also chamfer sharp edges, and add supportive loops to it. So, you do not actually need to worry about adjusting those things while working on the base model, unless you are planning to use it as lower level of detail, which we are going to uncover in a dedicated videos. The approach we are following so far is similar to the concepts of designing in CAD software such as Alias or Speedform. However, we are not targeting the dense geometry with that large number of polygons. We need to control the added amount of polygons and direct the flow for some loops to control or dictate Turbo Smooth modifier behavior. In order to use it efficiently and to minimize the optimization process required after committing to the changes the modifier has added to the form. So far, you have witnessed working with that amount of polygons require a lot of effort and a lot of time. We need the form to be as low polygons as possible, even lower than the current number. we need to correct the inside supportive edge loop, and create another outside. Also, we need to balance their tension over the main edge. As we discussed early, in the concept of designing, we need to correct the edges over this main loop, in order to adjust this weird shadows. When using set flow over a ring loop, it might not work as intended. In such case, select few edges from the loop, set their flow, then move gradually to the rest. The loop direction flow we have created so far is regarding to the separating lines that define the vehicle parts. However, it is not just the separating edges or loops, there will be also UV map separating edges. Although they are not as much important as the vehicle parts separating edges. For the sake of a perfect design, you should keep that into your consideration when correcting the flow of the front and the rear vehicle bumper. Let me remind you, our project is to create a game-ready vehicle, and that will require a UV map for its parts. We might uncover this at the advanced stage. There is a lot going on in this area. For better understanding, let's analyze its flow direction. We have main loop coming from the top and directed to the left. Then, another main loop coming from the right to the left. Also, we have a third main loop coming from the top to the bottom. These main loops define the shape of the form, and I need to keep them exactly where they are. The flow direction achieved by these loops is coming from the top to the left. This flow will direct the shadows and the reflection that happen on this area. However, we still have another side or edge loop that coming from the side to the bottom and interrupting the flow of our main loops. It is also creating a star vertex, which is a vertex that connect 5 or more edges. We have another star vertex on top of the surface. In fact, we have 2 of them. But they cannot counteract the tension caused by the star vertex at the top. The Turbo Smooth modifier can solve any star vertex that located on the surface. However, it cannot solve the star vertex located on a main loop correctly. This explains why we have this little bump of shadows or flow where the star vertex is located. This might be acceptable in certain cases, however, it is not acceptable in our case. We need to solve this star vertex in order to correct the flow direction. I will also solve one of those surface star vertices during optimization, and I will leave the other to the Turbo Smooth modifier. If you completely understand this, you will start to see things from a different perspective. You can direct the flow by using reversed loops to preserve or refine sharp details. Now, we have created some tension that trap the area in between these reversed loops. This is not the final optimization or the flow direction. We might need to do another one after completing this base. I have two questions for you. 1. How many star vertex we have on this form? 2. How many star vertex we need to solve?